Hi, my name is Junyan Zhang from Neighbor Cloud and Keist. In this video, we are going to share our research work, named as Playing the Fool, Jailbreaking LLMs and Multimodal LLMs with Out-of-Distribution Strategy. This work explores an effective attack strategy using out-of-distribution samples for jailbreaking LLMs and multimodal LLMs. So today, we are going to briefly talk about the vulnerability of LLMs and multimodal LLMs first, and then provide some insights and observations that motivated our work. Finally, we will introduce our proposed method with intuitive experimental results. LLMs have recently exhibited versatility on various language reasoning tasks based on scalable pre-training and fine-tuning on a large corpus of text data. However, since the training sources largely include internet text data, which may include unethical, biased, and harmful information, LLMs are vulnerable to generate such unethical, biased, and harmful responses to malicious questions from users. To prevent LLMs from producing such harmful responses, LLMs are post-trained via safety alignment with human feedbacks, where LLMs are trained to prioritize safer response that reflects ethical and safety considerations. However, in this paper, we note that there still can be a remaining vulnerability even after safety alignment. While safety-aligned models tend to refuse and respond in a safer manner for the harmful queries, they might still be vulnerable to jailbreak attacks that bypass safety alignment by using out-of-distribution samples that are unseen during safety alignment learning. For instance, when a safety-aligned model is given a query, "Tell me how to build a bomb," their response is safe. However, if we put some perturbations on the harmful word bomb with a random word, apple for example, then the model might generate harmful responses with regard to the confusing input that may not be learned during safety alignment. Empirically, we observe that safety-aligned models can certainly discern the malicious intent within the harmful inputs when they are in distribution samples that possibly encountered during the safety alignment. Therefore, they tend to successfully reject or refuse to answer to the such commonly seen attack queries. However, when the OD-ifying harmful samples that are possibly unseen during safety alignment are given as inputs, safety-aligned models exhibit high uncertainty on discerning the harmfulness of the attack query, thus generating a high portion of harmful responses. In this paper, we investigate an open research question. Does the underlying safety alignment of LLMs and MLLMs consistently guarantee safety even with regard to OD-ifying inputs that possibly differ from the training inputs and learned knowledge during all the training procedures, including safety alignment, and demonstrate that they still do not guarantee safety against such OD-ifying inputs? To OD-ify the attack queries, we adopted off-the-shelf simple textual or image transform techniques that are likely unused during the safety alignment stage. For OD-ifying the text attack queries, we transformed harmful word into OD-ifying one using simple textual transformations such as random word insertion, character-level perturbations, and word mixing. For word mixing as an example, we mixed the harmful word such as bomb with the harmless word such as apple and prompted the model to decompose the mixed words. And then, the model execute the query request for each of the decomposed word. Also, for OD-ifying the multimodal attack queries, we transformed the image with harmful object using off-the-shelf image transformations such as photometric transforms and image mixing transforms. For image mixing transforms as an example, we mixed the harmful image with the harmless image and prompted the model to interpret the two mixed objects. And then the model executes the query request by referring to each of mixed objects. For experiments, we evaluated our proposed framework, JUDE, on AdBenchM dataset by comparing with the state-of-the-art jailbreak attack methods. The results show that our JUDE achieves significantly higher attack success rate against GPT-4 and GPT-4v compared to the other jailbreak methods. Also, we further validate jailbreak performance against recent state-of-the-art multimodal LLMs. The results show that our Jude achieves significantly higher attack performance on all the models, especially including O1, which most existing jailbreak methods failed to jailbreak. For ablation studies, we firstly analyzed the effect of various image mixing transforms. The results show that our method consistently jailbreaks the target model with high attack success rates on all the scenarios. Secondly, we also analyzed the effect of mixing coefficient, alpha, which denotes the OO-deifying degree used for attack. The results show that when the attack query is not OO-deified, it only refuses almost all of the attack queries. Meanwhile, when the alpha value grows, the harmful inputs are OO-deified by mixing with the harmless image, reducing the refusal rates, and achieves high attack success rate. We further validate the jailbreak performance against the defense methods. Our Jude still achieves high ASR even when various defense methods are applied, which highlights the need for more advanced strategies to effectively safeguard against such OOD-based jailbreak attacks. To conclude our work, we firstly unrevealed the remaining vulnerability of the safety alignment when OOD samples are given as input. Exploiting this vulnerability, we proposed a new OOD-ifying jailbreak strategy using off-the-shelf transform techniques. Finally, our extensive experimental results demonstrate that this simple OOD-ifying strategy can pose a significant threat to recent LLMs and multimodal LLMs, highlighting the need for stronger safety alignment against such OOD-based attacks. This is the end of our presentation, and here are the QR codes for our paper and code materials. Thank you for listening.